Let's review what you've learned in each one of these apps. When I first introduced the apps, I told you what you were going to learn, but you'd never seen it, so it probably didn't really resonate the way it will now. So let's go through and just kind of review really quickly. And if you want to reinforce one of these concepts, just jump back to either the concept video from that app or the code, or play around with it some more. So in app 1, this was our simplest app, was the Hello World app. Remember, the goal was really to test your Python environment, get your editor set up, things like that, not really to prove that you can write print Hello World. That's silly, right? So we sort of introduced PyCharm here. We talked about variable strings and accepting user input. And this was really sort of getting our feet wet, getting started. Next up was what I kind of considered our first real app. That's Guess That Number game. And remember, the computer would randomly select a number between 0 and 100, and then it would tell the user, hey, you're too high, too low, as it took in the guesses. So in order to do that, we had to understand Boolean conditions. We had if, else, else-if statements, while loops. And when we start talking about these concepts like if-else statements and while loops, we have to talk about the shape of a Python program. And here you learned about the white space and indentation and how the smart editors help you with that. We also talked about string formatting with the curly braces to sort of generate strings in a much nicer, more flexible way. And we got the very basics of functions going there as well. App 3, When is my birthday? This one was all about dates, times, and time spans. Now, these can be tricky in Python, so I made this special app just to help you become comfortable with those and sort of reinforce what we learned in the first two apps. App number 4 was our journal or our daily diary, and this was pretty big. We covered a lot of stuff. This was our first sort of major app, I would say. And because it was a bigger app, we actually broke our code into multiple files. We had our journal module and we had our main program.py, and we had those work together. We did a lot of file I/O. And to facilitate that, we did path management in an OS independent way using, not surprising, the os.path. We used for in loops and iterators, obviously playing a key role in the for in loops. Because we had these different files, we might want to reuse the methods and features of one of those modules. And if we have been just calling main or just writing our code directly, like right in line there, we wouldn't be able to import those. So we talked about the dunder name convention to differentiate between when your program itself is being run and when your script is being reused. Also, we talked about documenting our code with docstrings. App number 5, this was our weather forecast app. We went out to Weather Underground and we grabbed the HTML, and we did that using a technique called screen scraping by making an HTTP request, using the request package, pulling that down, taking the HTML, send it off to the beautiful soup package, and then writing CSS selectors against that in memory to actually pull out the data we want. In order to get requests and beautiful soup, which are external packages, we used pip, and we could further isolate our particular environment and our application using virtual environments. Along the way, I also got to introduce you to a very Pythonic concept called slicing. App 6, I hope this one made you laugh. This is the lolcat factory, and this was all about consuming services and working with binary data. So recall, we went out to our lolcat service, we downloaded a bunch of binary images, and we saved them to the file system, and then we used Python's subprocess capability to launch the Finder or folder browser or Explorer, depending on your OS. We'd launch that up to actually show the UI, since we're not diving into things like PyQt and so on. App number 7 was our Dungeon and Dragon style wizard game. This was one of my favorites, and this one is about a very core concept in modern programming and Python: classes, inheritance, things like that. So we talked about how you create classes and model your data structures with classes, and inheritance allows us to sort of separate that into layers so it's more reusable, more manageable. Python has magic methods, sometimes referred to as dunder methods, like dunder init, dunder stir, for overriding behaviors of our classes, our objects. For example, we can write the dunder init to take control over the creation and initialization of our objects. And speaking of initialization, we saw when we're doing inheritance that you need to be careful about chaining these together in the correct order so the whole hierarchy gets set up correctly. Typically, this is where you define your fields in these dunder init methods. And when we're using our objects, you don't have static typing in Python. Instead, we use something called duck typing to achieve polymorphism. In application 8, we built a file searcher app, and we got to feed a ton of data to it. Remember, we had our 2.27 gigabytes of text while we were searching with this thing? So In order to make that much more performant and efficient, we used generator methods using the yield and yield return keywords. And because we were trying to process a hierarchy, a tree of data, the file structure, we used recursion, which models that scenario very well. In app 9, we got a hold of that comma-separated value data on the Sacramento real estate market in 2008, I believe it was. And we loaded that up and we did all sorts of interesting processing on it. We saw that at the heart of Python are dictionaries, and dictionaries, of course, played a key role in our comma-separated value processing as well. We wanted to sort the data that we got back out of that file, and we did that by passing a method. We saw that methods were first-class objects in Python, and when you want to write really small, concise ones, it's much better to use a lambda method or a lambda expression rather than creating a method somewhere else and just so that you can pass the name in where you are. We talked about the CSV file format and how Python has built-in support for processing that. We also saw that we can run into a situation where Python 2 and Python 3 behave differently. Remember, we had the statistics module that's in Python 3.3 and above, but not in Python 2. And so we wrote special code to sort of do a polyfill or fill in that missing piece for Python 2. And the consumers further down in our app didn't have to worry about whether there was a statistics module. We introduced a less efficient but sufficient one for them to use. We also saw that many of the situations that are solved with loops and lists, so looping over a bunch of data, doing some tests, adding it to a list, thing like that, can be solved much more concisely with list comprehensions. And while solving problems with lists is great, in app 8, we saw the performance implications that you can run into if you're processing a lot of data in a pipeline. So in app 8, we use generator methods. There's a similar concept in this comprehension style called generator expressions. So we use those generator expressions to create efficient data pipelines. The last app we built was app number 10, the movie search app. This went out to the Open Movie Database API and it pulled back data. And that was interesting in and of itself. We were processing JSON and things like that. But the key focus of this app was to build reliable code. When you're writing network-based code, chances that the network are down are pretty good, especially if you're running on a client machine like a laptop where the could be out of Wi-Fi range or whatever. So we need to be able to handle those errors. We introduced the try except block to do that. We also saw that you can use multiple except blocks to handle errors by type. Remember, put the most specific one first, the most general one last. We also talked about validating arguments by raising errors. We had some kind of argument passed to an init method for a class. The init method doesn't have a return value that you can pass back and say false or none or something like this, but we still wanted to validate the arguments coming in. And so we thought that we could raise an exception when invalid data was passed, and then the object would never even be created unless it started out in a valid state.